Okay, so this is notes for our similar figure. Goals are to identify similar polygons, find missing value, and describe a sequence that exhibits a similarity between two-dimensional figures. So, similar polygons are polygons that are said to be similar if the corresponding angles are congruent and their corresponding sides are proportional in length. So, you can see our corresponding sides. This 6 corresponds to this would be 3, and this 4 corresponds to 2. And they are proportional. Similar polygons. Matching sides of 2 or more polygons are called corresponding sides, and matching angles are corresponding angles. So you've heard us say that a side corresponds to another, and angle corresponds to another. So it is the same leg but on a different figure. Or the same angle on a different figure. Definition of similar polygons. Two polygons are similar, and here's the symbol for similar, if and only if their corresponding angles are congruent, this is the symbol for congruent, and the measures of their corresponding sides are proportional. Now, scale factor. Scale factor refers to the rate of change between two sides. So it means that all sides of the original figure are multiplied by the same number to get the length of the corresponding sides of the second figure. So this is saying that the sides must be proportional. So basically that's saying whatever I multiply the first side by to get the second side has to be the same, or the figure will change. So that means that this side corresponds to this side because they're corresponding, and I multiplied 3 times 3 to get 9. So that means that I have to multiply this 5 times 3 to get 15 if they are in fact proportional. So the scale factor between figure A and B is 3. Alright, so find the value, you have example 1. Find the value of x, y, and the measure of angle P if PSB is similar to triangle QPR. Now we spoke about in the geometry unit how the angles that correspond in similar figures have congruent angle measures. So that means that this angle is congruent to this angle. So when it asks for angle P, we look at angle S. Angle S is 86 degrees, so angle P is 86 degrees. So angle P equals 86 degrees, and that's because angles measured in similar figures are congruent. Now, we have to figure out, so we check that part off. Now let's find x. Okay, well, this gives you 4, 7, and x. Okay, so I need to find x. So I need to figure out what corresponds with. Well, let's pick 4, and let it correspond with 6. So if I set up my proportion, I've got 4 divided by 6 equals, and now I have to follow that same pattern. I pick the bottom leg. So that is x, and I put this triangle here first. So I now have x over 9. So now I can cross multiply, and I get 9 times 4, which is 36, equals 6x. Now I solve for my x. Divided by 6, x equals 6. So that means that the value of this side right here is 6. And that's because it is proportional to the figure QPR. And we will try the other one to figure out our value of y. So let's still use this 4. 6 over 4 and 7 over y. You have to follow the same pattern. If you go small to big, if this is small to big, you must follow the same pattern as small to big. Okay? So now we cross multiply. We get 4y equals 42. Divide by 4, divide by 4, and we get 10.5. Okay? So now our figure, because I did this 7 to this y, so now our leg for y is 10.5. So we have found x, y, and the ankle piece. And we did that by setting up our proportions and then relating our smaller figure to our larger figure. Now we have trapezoid A, B, C, D. Now that we can have similar figures that are not triangles. And it is similar to PQRS. So we want to list all the pairs of congruent angles and write the ratios of the corresponding sides in a statement of proportionality. All that means is I want to write what angles are proportional to what angles. Okay? So A, or what are congruent. So A is congruent, is congruent to angle P. Angle B is congruent, not in order, is congruent to angle S. And the rest of those you can fill in, as you can see down here below. Now, we want to compare the sides. So if you set up these proportions. So if I set up that, whoops, excuse me. I set up and I said AB over PQ, okay, side to side, and then BC over QR. So I'm comparing the same leg on the opposite figure, right? And then I have CG is over RS and AD over PS. Now I could put any of those together in any combination because they are proportional. So I could say AB over PQ, CD, or equal CD over RS. Okay, all of these relationships are proportional because it's taking the side from figure A, comparing it to side figure B. Okay? Now feel free to pause this, stop this, rewind this, whatever you need to do. Alright, so now, here I want to find out what is my scale factor. Going from 5, 4 to 10, 8. Alright, so what do I need to multiply my 5 by to get 10? Okay, so how many times bigger is the blue shape? What did I get? I got that 5 times 2 gives me 10, and 4 times 2 equals 8. So 2 is my scale factor. So now let's look at this translation. So instead of going small to big, we went big to small. So we're looking for the amount of reduction. So we see that 6 to 2, we know that we immediately divided by 3. But both 6 and 9 reduce in size by dividing by 3, but scale factor must be a relation by multiplying. So how can we multiply 6 by something to give me 2? Okay, so for 6 to become 2, you must multiply by 1/3. And for 9 to become 3, you must also multiply by 1/3. So your scale factor is 1/3. So when you are decreasing in size, you will have a fractional scale factor. Okay? You have a fractional scale factor. Now, what did we learn about similar polygons? We learned that they have equal angles. We learned that they have different sizes. We learned that they are of corresponding size. Whoops. We learned that they have a size change factor, or we call that a scale factor, and that they are the same shape. So that is our note for similar polygons.